Hello, I'm Paul Cox, your host for the second of three special star parties where we're learning about the sun. In the first episode, we learned about the solar cycle, the features we can capture with Slooh's remarkable solar telescope, how to use the solar telescope, and our sun-related quest learning activities. Now, in this episode, we are going to explore the solar features that we can't always see through the solar telescope, including the solar wind, solar flares, coronal mass ejections. Those are known as CMEs. If you hear us say CMEs during this, we mean coronal mass ejections. Now, in the third and final episode, we're going to learn how some of these events pose a threat to our satellites and our power and communications infrastructure when Earth is bombarded by the high energy particles that we're going to talk about today. We're also going to be looking at how some of that solar activity is responsible for what I think is the most beautiful sight that we can see in the night sky, and that's the aurora. And wow, we were certainly treated to some frankly mind-blowing displays last week during one of the greatest solar storms for years. And we're going to be talking about that in a lot more detail in the last episode. But let's get started today. I'd like to welcome Slooh educator and expert guest today, Keith Wozleski. Welcome back, Keith.
Thank you for having me, Paul. It's a pleasure to be here as always.
Well, let's get straight underway. No time like present. And let's start with what's called the solar wind. What is that and where does it come from?
Okay, well, let's talk. If you remember last time, if you were with us, we were talked about the atmosphere of the sun, the chromosphere. The sun has an outer atmosphere, and that's where the solar wind begins. So we call this the corona. This is an image that was taken by one of our Slooh members at during the last solar eclipse about a month ago. So this solar wind begins here in the corona, this very, very hot region, outer atmosphere of the sun, energized from all of those prominences and filaments and explosions that are coming from the granulation that we see on the sun. So that superheats this region and also contributes to this thing that we call the solar wind. It is a type of wind that blows out of this coronal region and away from the sun in every direction. So that's the beginning of where we start to see a lot of this activity.
Okay, so there's this stream, as we can even see there, we can kind of see the solar wind. There's this stream of potentially lethal and damaging particles heading towards Earth during solar storms like we saw last week. But is
Yeah, of
there
course. I mean,
anything that
the,
protects
the
us?
solar wind will,
Is there anything that protects us
there is
from that here on Earth?
yeah, the wind will carry all of these ionized particles from the sun that are released either through these explosions that we've seen last time around, or any of the other material that we're going to look at, like these coronal mass ejections that you're
Mm.
talking about. So as these are propelled into space, we on the Earth are protected. So if we can move, we're going to look at the comet first. This happened. This the
Oh,
comet.
yeah.
This is Comet 12P Pons Brooks that on its way around the sun ran into this solar wind, and we can see some distortion of the tail and also the brightening of the coma, the brightening of the
So
core of that
this
comet.
so this is an image that Slooh member David Malik made, and normally we'd see that tail just streaming along in a very straight line, but there we can see there's this huge kind of, it's almost like it's been punched, and we have seen, Keith, on certain comets with very long tails over the years, where there's actually been what's called a disconnect event, where the solar wind has actually snapped the tail virtually, and it's spewed it off into space. I think we've got another one of these as well, haven't we, to see? Look at this one.
Yeah, same idea. I mean, just a wonderful thing, and it shows the power of the solar wind. When you
Yeah.
have something like a comet like this, in approaching the sun and getting ready to get slung back out to where it came from, to have this wind distorting the tail. It's not the only thing the solar wind distorts, but this was just kind of a rare event that we don't get a chance to
Wow.
see very often. So I thought
So
this was
they
great.
haven't got very much protection. Those comets have not got very much protection from the solar wind. But you were saying that Earth has. So what's protecting us here?
Let's take a look. The Earth has a magnetic field. So here we can see the ionized particles and plasma and solar material approaching the Earth, but we have this protective bubble, the magnetosphere. The particles will hit and kind of be deflected from the face from the nose of this magnetic field and will kind of loop around the back into this tail. You'll also see at the top the almost like a funnel. And
Mm.
that's where, the magnetic field is weaker at the poles, so the charged particles will get caught up in that funnel and uh, gravitate down towards the poles, some of them.
Keith,
And
we're also seeing a big teardrop shape in the magnetosphere. Is that because the solar wind is so strong that it's actually distorting the magnetic fields?
yes, the solar wind is so powerful that it will distort somewhat the magnetosphere, the magnetic field of the Earth. And we do have a day side and a night side. So if you notice that day side is more intact, it's more of a bubble. And
Mm.
then on the nighttime side, on the back side, we have that trailing tail
So
effect.
what's this one showing us?
So this is an image of the largest magnetic field in the solar system. This is what the magnetic field of Jupiter looks like. This is probably an artist's rendition, but again, we see that same protective bubble in the daytime side of the field, and then that trailing tail in the backside in the nighttime side. It's just enormous. I mean,
It
Jupiter is
is.
how many times larger than the Earth?
Have we got another diagram showing the true scale? That's showing the true scale. Look, its magnetosphere is stretching virtually all the way out to Saturn's orbit. It's absolutely amazing. So it is very well protected, but we do see aurora. Maybe we'll talk about this during the last show. We do see aurora on the other planets as well, don't we?
Yeah, we do. And I think the exciting thing about this is not just that it goes out into Saturn's orbit. One slide I didn't show was the image of the magnetic field of Mars, because Mars doesn't have one. So
Yeah,
it's not protected, and that creates all kinds of problems, and maybe we'll talk about in another episode. So
exactly.
Jupiter,
Yeah.
very well protected with this huge magnetic field, the largest in our solar system.
Now, Keith, one thing that we didn't speak about before we came on air is we've got the magnetosphere helping protect us in this stream of high energy particles, but there's also other things that are helping us as well. We've got the ionosphere, and we've also got our atmosphere as well is helping to slow down those high energy particles so it doesn't actually hit what they would really be harming, which is human life, biology, but also our electronics and stuff like that as well.
Exactly right. It's not just the magnetic field, it is the atmosphere. In fact, the atmosphere absorbs many, many harmful things, especially radiation and that
Mm,
kind of stuff that could cause damage to people and animals. Yep.
yeah. So that's the solar wind. I've learned a thing or two there. Thank you very much for that. But you explained that solar flares and coronal mass ejections contribute to that solar wind and can make it stronger, just as we've seen over the last week. So let's learn a little bit more about each of those. Let's start with solar flares. What are they?
So the solar flares, we see they become bigger and more frequent as the sun approaches this period that we call solar maximum. And they are visible in the Slooh telescopes as these very bright
Yeah.
patches. So this is from what I call the mother of all active regions. This was AR 3664. The agencies that detect space weather number these events, and this is just huge. I mean, this was the talk of the solar telescopes all last week.
Yeah, so
There
this
were
was
actually
Friday, wasn't it? That we were
um,
we were witnessing, these continual flares, bubbling off, and it's the white area there that's appearing is the actual flare. But you were talking about, why it's important that we
again, the flares
understand.
are
Sorry, you, you carry on, Keith.
no, it's okay. The flares are these explosions of heat and light and radiation and energy, and they can last anywhere from minutes to, a couple hours. And this was again what we saw on Friday. This is a wonderful time-lapse animation that you made, showing how the solar flares can be detected right here with the Slooh telescopes. This region, this active region, is just enormous. I think this was actually two regions that joined together and is moving towards the limb of the sun, the edge of the sun. And it has passed. I checked the solar telescope today. It's gone. So
Yep.
it's making its way to the other side of the sun. And I think the big takeaway here is what's going to happen in another 2 weeks as the sun rotates? Is this going to return in another form? Maybe it'll get smaller, or will it get bigger? It's going to be interesting to find out where we go with this.
So one of the points I was going to make about this is that students using Slooh can actually be monitoring the solar telescope, and they can see a flare like this, and they can actually embark on the forecasting of solar storms. They can start to do that, and we're talking a lot at the moment at Slooh about workforce development in the new space industries. And last week's solar storms, we're going to talk about this big time in the next show, but they affected the satellite operators to a huge extent. And being able to forecast these kind of storms is incredibly important. But Keith, carry on about flares to the next slide because it's a wonderful one, this one.
Okay, yeah. I like the other one. Oh, but we can use this one too. This again, this heat, light, energy, radiation coming from the surface of the sun, usually from an area of sunspots. We talked about that in episode 1, where you have this magnetic field activity going on. And when these field lines become twisted and turned, they can snap or they can reconnect. And when that happens, we have these massive explosions of light and heat and radiation. And because this is light, it will travel to the Earth at the speed of light. So the thing I like is that by the time we detect or see a solar flare, we've already been hit by it.
Yeah.
And we are going to save that discussion for episode 3, but it's just an interesting
Yeah.
little fact. It is light and it will travel at the speed of light. It takes about 8 minutes for light to reach Earth from the sun. So,
And
uh,
that's when we're going to talk now about coronal mass ejections. That's a really important thing to be thinking about, because bang, a flare is letting go of these, ejecting these, photons which are traveling at the speed of light, and they reach Earth in 8 minutes. But coronal mass ejections, that's something slightly different, and that takes longer, doesn't it, Keith? So let's talk about those.
it does. So this is a diagram that shows basically what happens. Coronal mass ejections are actual explosions that are part of the sun's plasma. It is solar material. It's not just charged particles. It's actual bits and pieces of the sun that are cast off into space. So I like to use the example of the rubber band. You think of rubber bands being stretched and twisted,
Mm.
and sometimes they can snap, and when they snap, we have that explosion,
Yeah.
like we saw with the solar flare. CMEs do not necessarily have to be linked with solar flares. A lot of times people get this confused. They are different things. They're different events. Coronal mass ejection can be preceded by a flare. They can happen at the same time. The flare can happen after the CME. But the big thing is, depending on how much of this stored energy there is in that rubber band that we're talking about, will determine how much of this plasma is ejected out into space. And the thing of this is, because it is matter, it takes longer to reach the Earth than does light. So the estimate is anywhere from anywhere from 1 million miles to, I think, 8 million miles an hour. Why is there a difference in time? Because it depends on how powerful the explosion was. So if it was sort of on the weaker side, it might take might take it a little longer to get here. If it is very, very powerful, very strong, it will get here a lot more quickly. Anywhere from 18 hours to 3 days is the usual projection for a coronal mass ejection to get here at the Earth. The nice thing about it is, because it takes longer, you can prepare for this.
Yeah.
So you know it's coming, not like the solar flare.
Yeah. And that's exactly what all of the infrastructure companies, the power companies, and the satellite operators were doing last week, because we were watching both in the Slooh telescope and in the space telescopes like this. We were able to see these anomalies happening on the sun, actually observe them, and then we would be able to prepare for them. So what are we looking at here? What I can see, Keith, I'll add to this, the two bright spots on either side of the sun here. The one to the left is Jupiter, the one to the right is Venus. But why is there a big dark patch in the middle of this?
This is where we have that special tool that I talked about, the chronograph, and that's what we use to look at these outer regions of the sun, the region of the corona, the solar coronal mass ejections, the CMEs. The dot in the center actually represents the size of the sun, and the corona is obscured by that outer blue circle. So we get to see just how big these ejections of material are. I mean, they are enormous. They're huge. And this one was kind of, I think, so we're looking at the day here, the 9th, 10th. So
This spans the six coronal mass ejections that happened over those couple of days, I think.
yeah, okay. So this was from that same active region that we looked at that was
Yeah.
not just producing flares. I think it produced 9X class flares, also producing
Wow.
all of these coronal mass ejections. So whatever we saw with issues with communications and whatever we saw in terms of aurora that everybody's been talking about, there's going to be more of this. There are other active regions on the sun as the sun turns. This was the parting shot, I think is how this was listed in the
Yeah.
some of the literature. You know, this is kind of the goodbye kiss that this immense active region
Mm.
sent towards Earth. Let's hope that it does more of this on the other side of the sun and not when it makes its way around again.
Exactly, because a lot of the stuff that we're seeing here, of course, is being projected out, not in our direction. But there are some little moments there where we can see some little white lines scattered over the image, and that's some of those high energy particles actually hitting that space telescope and hitting the sensor in the camera. I think we've got another one of these as well, haven't we?
Yeah. Yeah, these are just great images. And, you know,
Mm.
that's kind of the nice thing to think about. You know, when we see these active regions on the face of the sun, it's almost like zooming in on a target, except the Earth is the target.
Yeah.
And it depends on where these decide to start spewing out material. As long as it's away from the Earth, nobody really cares very much. But space weather, which is the branch of science that studies this type of activity, keeps a very close, very careful eye on what's going on because of what it can do to us here on Earth. And, you know,
Yeah.
we'll talk about that in episode 3. Just know that these events are very exciting, but we do have to keep an eye on what they're doing and where they are.
And now we've got this whole raft of spacecraft who are continuously monitoring the sun from all directions in all wavelengths. What are we looking at here, Keith? Because I think this is a lovely section of video.
Yeah, so these are some animations that just to show again more of the same thing. These coronal mass ejections. Some you'll see some solar flaring. You see bits of the corona, bits of these charged particles flying through space. And just amazing, amazing footage that we're even able to see these types of things. Don't
Yeah.
forget, it's only within the last, 50 years or so that we're able to even study the corona. Used to look at the
Yeah.
corona during a solar eclipse. Now we have this beautiful specialized telescope that has a central obstruction that allows us to cover that up so we can actually study these events.
What I loved about this video is that little bit there where they've actually superimposed the the images of the sun, but then on top of that coronagraph that you were talking about. So we actually see in that little clip the flare on the surface of the sun, and then this huge ejection coming off from the coronal mass ejection. So I do love that. But anyway, thank you very much, Keith. That's pretty good stuff. I think it's so exciting to see this, and we were watching all of this activity unfold in the Slooh Solar Telescope last week, and then we were able to watch the Slooh. The space telescopes as well. And I was going through the member group on our Discord server today, and that's where actually I got a lot of these images and animations from because they were sharing that as it was happening last week. But if students and members want to learn more about the sun, we've got some Quest learning activities that they can take a look at, haven't we, Keith?
Yes, we do. We have 4 very popular quests. So if you're brand new to the sun and have never read about the sun or studied the sun or understand anything about the sun, Sun Explorer is a good place to start. It's kind
Yeah.
of like a pre-beginner quest. We have another beginner quest, Our Dynamic Star, where you can continue what you did there. Again, you're snapping pictures from Slooh Solar Telescope and adding them into the quest. Very simple to do. There are lots of guidelines and walkthroughs that help you along the way. After you've completed those 2, you can move on to our Radiant Star. And that's where we get into the nitty-gritty of what happens at the sun's core. We talk a little bit about nuclear fusion and how the energy at the sun center bubbles up to the surface and provides us with life here on Earth. And the
Yeah.
final solar quest is our rotating star. The sun rotates on its axis about once every 27 days. So you can track one of those solar features that we talked about in episode 1 and watch it move across the face of the sun as it rotates. So 4 exciting quests that students can take part in to learn more about our center of the solar system, the sun.
They are, and they're such good fun, those quests, especially when you've got such a high level of
That they are.
activity as we've got now. And we'll maybe see tomorrow when I think there's some clouds today, but maybe see tomorrow. I was spotting quite a lot of new activity rotating into view, Keith. I don't know if you saw some of that, so that's going to look rather exciting. But anyway, thank you very much for telling us about the Slooh quest. I think that is it for this episode. A huge thanks to our expert guest, Keith Wozaleski, today, and to Gretchen Bickett, our event manager and producer. Don't forget, we've got one more episode coming up where we're going to be learning about why we should care about these events and the potentially catastrophic damage they can cause to our satellites and power networks. We'll learn about one such geomagnetic storm, the strongest recorded in 1859, and of course the events from last week and the effect it had on satellite operators. These events will not only happen again, they were happening last week. They're going to be happening again and again, but are we ready for them in this new space age? That's what we're going to be talking about in the next episode. And if your students are interested in a career in the ever-growing space industry, we'll take a look at how Slooh can be used as a tool for workforce development and give them a pathway into those industries. But for now, that's it. Thanks for joining us. Clear skies, everyone.